So Tyler, the way we've been doing this is basically I hand over the reins to you. So I'm going to make sure you're a co-host. Where'd you go? There he is. Hey, man. Is it cold there?
Hey, how are you? A little bit, yeah.
Yeah. There he's going. I can see the coat on. All right. And so you should be able to share your screen as necessary or whatever. And so the hope is that you can sort of quickly hit the highlights and then we can have a discussion.
Great. Yeah, that sounds great. I will just take 1 minute and
just to
share
everyone
this.
else, Tyler McCormick is a professor at University of Washington. He's one of the world's leading experts on network sampling methods, including some just truly remarkable work on the network scale-up problem. And he's now turning that work to these questions about inferential problems when you have missing data. And as is often the case in networks, these ended up being much more complicated problems than they seemed at first blush. And so I'm really glad we have this, because so often in health, we have partially collected data, either by default, because we can't get samples on everybody, or just de facto, and then we get so many people not responding. So this is, I think, is a really valuable addition to the quiver of tools we have here. So Tyler, the floor is yours, man.
Perfect. Thanks very much. So just rearranging my screens here so that I can get to that should do it. Great. So yeah, so thanks very much for the chance to be here today, and for the sort of really kind introduction, Jim. I am yeah, so as you sort of saw in the talk, I sort of talked a bit sort of inference on partially observed network data, and this, what I reflect is really kind of sort of how raw sure really is, where in a sort of large fraction of cases where we would like to observe on an entire graph, it's just sort of not possible. And so what we do in sort of response to that, I think, sort of varies everything from trying to take a sample of egos and then to connection between those individuals and possibly the people that they're connected to sort of the other extreme, which we talked about, which was a sort of case where we're not collecting any.
Oh man, I think we might have lost him. Oh, there he is. Are you back?
Yeah, I'm back. Sorry about that. I'm not sure what happened. It just went away. All
right. Try again.
All right, let's do it again.
Hey, you sound good now, man.
Yeah, you were
Okay.
a little fuzzy there a minute ago. I think you might have just been having some traffic issues.
Oh yeah. Okay.
Right. Maybe if folks can turn their cameras off just to make sure that we're not.
My wife is also now. Yeah. Thanks. Yeah, sorry. Like I said, my wife is also, she's teaching now. And that sometimes it's usually okay with the router, but there's definitely a lot of traffic coming in and out of our house right now. So I'm just going to move over here, so I'm sitting next to it as well. Okay, so right, so the sort of highlights here, so as I was saying, I mean, there's a sort of really large range here of how we think about sort of partially observed network data, ranging from seeing a graph that's sort of constructed of a subsample of egos, all those connections. And so, really the reason that the sort of highlight that I want to hit here is, and the thing that I think that is often to me that it took me a while to sort of appreciate as a sort of networks researcher, is the sort of real interplay between sort of sampling and modeling that goes on in sort of thinking about networks. A lot of my work has been sort of focused on building models, and it's sort of only in sort of doing that process that I came to sort of really appreciate the sort of impact of the data collection process. And so I've just given a sort of little example here that maybe I'll sort of let be the highlight of the or the the kind of overview of the talk that you saw, which is just sort of thinking about how different your sort of summary of the statistics or of the sort of types of relationships that you see in this graph would really be the sort of two different sampling strategies that that I've highlighted here. And I think this has implications for both the way that we sort of think about the way that we think about sort of recovering particular statistics or descriptives from graphs, but also the way that we think about sort of the and I think this sort of goes into the goes from the sort of more traditional things that I sort of think of as the domain of kind of sampling survey type work in terms of the sort of potential. In the talk, I sort of showed that the sort of measurement error that you see sort of can't be characterized by the sort of classical attenuation bias type paradigm. It's sort of not predictably positive or negative, but it also sort of impacts the sort of implications of the way that we have built models. There's sort of interesting questions that arise about what happens when you have exponential random graph models under sort of the prospect that you're seeing a graph of a particular sample as opposed to the complete graph. And what if you try to compare two graphs that are two different sizes and that sort of thing. And the same thing as well for kind of latent variable type models and sort of the implications of sort of sampling when you think about sort of the graph growing and sort of taking larger and larger collections of graphs and sparsity and density and that sort of thing. So stop here since you've seen the talk. That's kind of the one thing that I think is that sort of the key to emphasize from my perspective is just how critical this data collection in thinking about sort of models for networks. And take questions. I'm happy to kind of talk through more of the topics in detail if folks would like. But since you've seen it, I'm happy to have the last half hour or so, or the next half.
Okay. I think you cut out right there at the end, Tyler, but I think you were stopping anyway. There we are. Okay. Yeah. So I guess again, thanks again for doing this, and maybe I would start if that's not too rude to be the host and also the first questioner. But I could you just spend just
please, yeah,
just a moment talking about why. And for those of you that didn't get a chance to see the presentation, one of the fun bits at the end of this is that it's the aggregated response data approach seemed to provide a nice solution to this problem, in the sense that you were getting estimates out of that model that were better than the estimates you would get without it, but also better than we could get from many of the other models. I wasn't able, I like that result, but I didn't have a good intuition for the why of that result. Is there a chance you could, so about what it is that you're getting out of that you wouldn't get from just the ego network sample before?
Yeah, and so you mean so the results?
Yes, exactly.
The ones that are on the screen, is that what you're? Yeah.
Yes.
Yeah. So I think you could try to do something similar in the ego in an ego network kind of setup. Yeah. So the point to make, I mean, the sort of type happens to let's see. Yeah. So I mean, so there's these kind of two approaches that I sort of talked about in terms of how we could think about adjusting for sampling. And you sort of have one approach, which is the sort of Chandrasekhar and Lewis, or sort of the predominant. Let me think about a particular statistic and think about if I can sort of work out, the implications of a particular design on the sort of, on the sort of required adjustment for that particular statistic. But then there's kind of the broader approach, which is to sort of say, which is to rely on a model, and to say, am I able to characterize, under the sampling design, am I confident in, if you can estimate the parameters of the model, then you can simulate from the model and then sort of recover a distribution over graphs. And so so you could definitely do this a similar kind of thing. But I wanted to kind of present. I wanted to present the sort of ARD case because it's really sort of shows you the extreme. I mean, it sort of shows you that, like, you know, it's about this sort of general paradigm of, you know, is there enough information in the data to estimate the parameters of the model? And if so, then you're kind of, you know, then you sort of can estimate across the class of distribution, across the class of graphs that can come from the model. And so I wanted to sort of show this example. You could do it in ego work, but I wanted to show this example, number one, because it's a sort of an and number two, because this, you know, I do an ego network context too, but I don't think, yeah, I don't think it's sort of put as a sort of explicitly. But basically, we can sort of characterize like what the properties of the statistics are that are going to have this this sort of feature that we can recover. We can recover sort of process. And essentially, it's this that, you know, as you render samples with the strategy that you're using, your sort of statistic is going to kind of, you know, that means that, you know, it should be pretty similar across draws from the graph.
Right. Yeah. So I think I mean, the data collection story that really this work drives home is that the data you collect still has to have enough support to be representative of whatever the model function would be that would create the network.
Exactly.
Yeah.
Exactly.
Interesting. Because I think the first approach that you point out, which is that we you know, essentially model the relations amongst the nodes you've collected, which is the, you know, first like naive thing to do. You know, there's a huge amount that gets missed there, and so
yeah,
it's not clear that that's. Yeah, I guess I can imagine situations where it would be right, but it's difficult to imagine situations where you would know you would be right. Right. So.
I mean, expand on what just a little bit, Jim, to sort of say, I think there's kind of two, you know, yeah, just to kind of combine what I was saying before with what you're saying now, I think sort of as a sort of possibly a succinct summary is I think we need two things for this sort of resampling approach. We need two things. One is there needs to enough.
Oh man, you were so cutting
data,
out.
like you of the model. Oh no, again. Oh man.
All right, try it again. Now you sound clear there.
All right. Okay. Good. Yeah. Yeah. I apologize. I'm sorry about this. It's normally fine when Rachel's teaching, but I don't know what's going on today. Anyway, so yeah. So I was just combine the two statements that there to be enough information. The sample has to have enough information to sort of recover the parameters of the model. And that's the first part. And then the second part is that the sort of statistic that you're trying to use has to be one such that you can, you know, such that if you see more and more information, the value of that statistic becomes consistent. And so, or become example of that, I think, is the sort of a very small fraction of the graph. Then I know, you know, some information about whether or not, you know, two people are friends. And as the graph gets like bigger and bigger and bigger, more information, but only enough to estimate the parameters of the model perfectly. You still have a lot of variability about whether or not two people are connected. Whereas if you can estimate the parameters of the graph perfectly, then something like an individual's degree is going to be much more stable as the graph gets, you know, as the size of the graph, as you see a larger and larger fraction of the graph.
And do you have a
the graph grows.
Gotcha. Do you have an opinion on the effect of? I mean, it's an obvious thing that happens when we do data collection, where we have to limit the number of people that a person can know. they can nominate. Have you thought about this framework as a way to, in lines with that kind of constraint for data collection often?
Yeah, so that's a great question. I mean, um, so it's something that I thought about. Definitely the sort of work out there that sort of indicates that that can create potential issues. And I have a colleague at UW, Alan Griffith, who's been on that as well. I mean, so one thing that's interesting there is sort of which you sort of get information on. So when you truncate, sort of how do people do that truncation process, and how does that sort of, are you getting a sort of specific subset of people in that truncation versus a sort of random sample of people that you connect with? So I haven't thought about that. The short answer is no, I haven't thought about that that problem put into this sort of general.
Are there other? I could talk questions on this all day, but I want to stop and give the rest of the audience a chance to jump in. I apologize. Anyone else have questions on data collection or data collection strategies in tune with modeling? All right, hearing none, I will dominate the conversation if that's all right. So I think the classic the reason we think about it is because it is that there is a there is this notion that that you point out in your presentation, right? That if you can model the shift that's been happening in the statistic, then that's the other solution to how these things can be built. And so the one thing we know about degree truncation is that if the one thing that's going to happen is that the degree is going to be higher. And the thing that our simulations that John and I and Jeff have done seems to show over and over. I mean, at least in those types of things, is that degree is the one measure that on rank in degree ends up being reasonably well estimated under a whole lot of different assessments, even when you bias the way in which people remember essentially their missing data. So I think that what I would like to be able to do, one of the things that I took from your paper was that because Carter Butts and I have a little bit of an axe here to grind, just to admit it, that Carter and I always fight over what, how you should do this, because it's the case is that there is no doubt that you get biased network statistics if you truncate the degree distribution, because the degree distribution does determine so much of the graph. But if we can know how it biases it, then I think then we can recover the other side of it, which is that if you ask people to nominate 100 of their friends, they're going to just ignore your survey and you're going to get nothing. So from the pragmatic, how do I collect data standpoint, you have to truncate. And so you want to find a way that you can truncate that still gives us information. And so the other thing that I thought from your talk, as it was listed in the as you came to this end, was that we could use this, how many Marys, how many Jose's do you know, as a way to augment data collection in the same way that you might use a social capital generator in a survey. That could make it quite nice. It's an easy question for people to answer, or it's a not horrible question for people to answer. And it might be informative in a way that you could just add it to the model that you didn't otherwise have.
Yeah, absolutely. And I think that's, I mean, so another sort of case where that happens is in responder driven sampling, right? Where you sort of need an estimate of the network size to get at the to get the sort of sampling, to get the weights to correct for the impact of the design and responder driven sampling. And so people definitely do that. Exactly what you're describing, Jim, in that setting where they'll say, let's ask a few of these, like, how many people do you know questions to estimate the degree. And then that gives you that gives you your sort of degree estimate for responder driven sampling. But yeah, I think that's a great idea of sort of using it in a general survey to be able to sort of estimate the sort of how much truncation you have. Yeah.
It's interesting because I suspect there are a number of surveys that have been done with networks that include different kinds of social capital generators.
Yeah.
So we could actually test this directly.
Yeah, that's a really great idea. Yeah.
Might be a fun paper. So if somebody's looking for a master's thesis plus, put Tyler on as a co-author and write that. I think that would be awesome. Because for the new people, that a number of people in the room are new social networks and health fellows and others who are just getting started in this field, and it really is a difficult trade-off. And just to highlight some of the ways in which these things work is that it's really hard to collect network data on individuals. And the main trade-off that people find when the first thing that happens when you start writing the survey is like, how many slots do you give people to give answers, or do you have them check off on the whole roster? And the trade-off and the kinds of biases that you can get from one version or the other are pretty strong. And so it makes it it's difficult. It's just it's an honest to God difficult problem to solve. So
yeah, I totally agree. And I'll just say, I mean, so by way of kind of what kind of got me excited about this sort of line of work, which I think sort of matches with what you're saying, Jim, is I kind of realized that there's there's a sort of a question I think we sort of have as a as a field or as a discipline of people who think about sort of data driven questions on networks. Should we have given that we have a finite amount of resources, should we have a few really, really high quality data sets that we all use? Or, should we have a lot more data sets that are, that are, that can't be as high quality, right? I mean, I think, I work with a data set commonly that's, and actually it's the one I gave an example of in the talk. I think that, the sort of cost of collecting the data for these 75 villages in India is, roughly, $250,000 per round. And so I mean that's a sort of substantial amount of resources sort of put into data collection, and that's a specific case where you can sort of collect entire graphs. I think there's a lot of cases where it's just sort of not feasible, an even larger sum of money. So I think that's sort of one of the questions that really motivates me is sort of how do we think about in settings where we have where we don't have a really great high quality data set, but we really have important substantive questions, what do we do? And yeah, I think like Jim's saying, it's you're making these trade-offs. That's what you do.
And being able to augment with two-mode data to ask, which is in many ways exactly what it's not used the same way, but you think about what the social capital indicators are. Saying how many doctors do you know, how many lawyers do you know, how many plumbers do you know?
Right.
That's in many ways the same kind of way. And so you can build a model around the fact that we both go to the same church, or and we know if we know the size of the organization, then that creates an edgewise model to inform the edges that you've already observed. And I think the extent to which we're able to estimate those kinds of things accurately is pretty high. The other thing, again, for those of you that didn't have a chance to get through the end of Tyler's talk, is that there's a nice discussion there of the role of latent space models, generally, which we talked about a little bit in the last session. Is that, and I think, and I'm going to put words in your mouth, Tyler, and you should tell me if I'm wrong, but part of this is that in many cases it might be possible to estimate the latent space easier than it is to estimate the direct network, and then you can essentially infer direct ties or processes on the direct ties from the latent space.
Yeah, that's right. Yeah. I mean, so I think I have a sort of summary here of exactly how this maybe
I think you just passed it. There it is.
There it is. Perfect. So that's exactly sort of exactly the idea of what we're saying here is that we can't estimate, from these questions, which are, how many people do you know with a particular name, or how many doctors do you know, for example. Like, I mean, of course you can't estimate the entire graph, right? Because you're not seeing any edges. But it turns out, I mean, and I think this is like, this is sort of one of like, yeah, I think one of the sort of most, a very exciting sort of continued process of discovery for me, where I think, every time I'm like, oh yeah, we must have, extracted all the data we possibly can from these how many people do you know questions, and it turns out you can't. There's something else. But so it turns out there's enough information in these questions to sort of estimate the parameters of a model for a network amongst the individuals in the sample. And then sort of once you have the parameters of a probabilistic model, then like you can generate graphs. And once you can generate graphs, you can get graph statistics. And so that's, I think that's the sort of the main idea of the approach that we've used. And like we've said with Jim's first question, I mean, you could do the same with an egocentric sample, for example, to try to estimate, sort of estimate the parameters of a particular model on the graph. And then once you have the parameters of the model on the graph, to sort of generate from that probabilistic distribution. And so that's why it becomes important to think about sort of exactly which statistics you're using in the regression too, right? Because even if you can generate the graph models, the sort of the graph parameters, you can sort of think about like an individual edge, sort of it's either there or it's not. Each time you generate the graph, it's still going to be really variable, even if you have really, really good estimates of the model parameters. Assuming your probability of the edge is not like 1 or something.
Right.
Yeah, exactly. Away from those boundaries, it's going to be really variable. But other things like degree and sort of measures of clustering and that sort of thing, like those are going to be pretty stable across draws from the graph distribution. So you have a pretty good idea of what it what the statistic probably is in your sample, even though you haven't seen any edges.
That's awesome. All right, so other questions or comments for Tyler before we let him off the hot seat, as the case may be? Your internet all of a sudden has got much better here towards the last little bit, so we can finally hear you again. So.
Yeah. So yeah, right. So I have my background here. So you didn't see me walking like past the router, past the toddler, down the stairs and into the basement. So I'm sitting directly under the router now. So
that'll do it. That'll do it. All right. Well, in the interest of keeping roughly on time, then I think we will let you go, man. And I just really appreciate you doing this.
Yeah, thanks. My pleasure. And I'm happy to talk with folks, afterwards if questions come up, or if you, sort of have, anybody wants to talk sort of further, I'm more than happy to do that. I really like, kind of thinking through these really complicated, data trade-offs that we've been talking about. So shoot me an email. I think, oh yeah, my website's on the slide, so my email's there. So yeah, feel free to send me an email and reach out if you have questions.
And for those people who are just interested in different questions about the basics of network data collection, we do have some videos on the basic website, on the training website that just discuss the differences between roster methods and enumeration methods and things like this. So don't be shy grabbing those. And as we said before, shooting us emails if you have questions about any of that. So that's kind of the purpose and goal of all of this. So. All right. So let's take 5, and we'll come back with the discussion of ethical behavior in the context of linked trace designs. We're not limited to linked trace designs in our discussion of ethical treatment. We've talked about it, privacy and other things, and so forth as well. So Dana's going to lead that discussion, and we'll see you all back here at 3:15 Eastern.